Let's do this question on question 12, which is the last question for this AHS prelim paper. This question is on integration. Okay, and sum differentiation is basically sum differentiation and application of integration, finding area under the curve. So the question over here shows part of the curve y equals to square root 3x plus 4. Now the line AB is tangent to the curve at point A. The points B and C lies on the x-axis and C is a point on the curve. The gradient of the tangent of the curve at A is 3/2. So find part I, the coordinates of A and equation of the line AB. So we know that the gradient of the tangent of the curve at A is 3/2. So what we're going to do over here is we're going to find dy dx. Okay? So dy dx of this curve over here is actually 1/2 3x plus 4, 1/2 minus 1 times 3. So this is actually 3/2 3x plus 4 whole thing to the power of minus 1/2, which is equals to 3/2 square root 3x plus 4. Okay? So because the gradient of the tangent of the curve at A is 3/2, right? So to find the x coordinate of point A, okay, we can equate dy dx to this gradient 3/2, which means that 1 square root 3x plus 4 is equals to 1. So square root 3x plus 4 equals to 1. So 3x plus 4, square both sides, I get 1. So x is actually, 3x is actually minus 3, therefore x equals to minus 1. So when x equals to minus 1, okay, substituting it into the equation of the curve here, we get y equals to square root 3 times minus 1 plus 4, which is equals to 1. So we have the coordinate of point A, which is minus 1 and 1. Right? So using this coordinate of using the coordinates of point A, okay, we take y minus 1 over x minus minus 1 and we equate it to the gradient of the tangent of the curve at A, which is 3/2. And this gradient 3/2 will also be the gradient of the line AB, right? So using this, we can solve for the equation of the line AB. So 2y minus 2 is 3x plus 3. So 2y equals to 3x plus 5, which means that y equals to 3/2x plus 5/2. And yep, we are done with 12 part I. So let's move on to 12 part II, but before that, let me write down the coordinates of point A over here, which is minus 1, 1. So here will be minus 1. Okay, so here will be 1. Okay, later we will need this, so I'm writing and labeling it in the diagram here so that it will be easier for the last part of the question. So find the coordinates of B and of C. Okay, so in the question, they already told us that B and C both lies on the x-axis. So because they both lies on the x-axis, right? For point B, we can use the equation of the line AC over here, AB over here. So think of it as, in order to find the coordinates of point B, we can simply just sub y equals to 0 into the equation of line AB. Okay, since point B is on the x-axis, so we get 0 equals to 3/2x plus 5/2, which means that 3/2x equals to minus 5/2. That gives me x is equals to minus 5/3. Okay, so this means that the coordinates of point B, okay, is actually minus 5 over 3, 0. Okay, so I'm going to write it down over here, minus 5 over 3, 0. So here is actually minus 5 over 3. Now to find the coordinates of point C, again point C is also a curve on point C is also on the curve, and point C is on the x-axis, meaning it's where the curve of y equals to square root 3x plus 4 cuts the x-axis. So sub y equals to 0 into the curve, y equals to square root 3x plus 4. We get 0 equals to square root 3x plus 4. Square both sides, we get 0 equals to 3x plus 4, which means that x is equals to minus 4 over 3. So the coordinates of point C is actually minus 4 over 3, 0. Okay? So let's label over here. So this is minus 4 over 3, 0. Okay, minus 4 over 3. So we are done with 12 part 2, and we can finally do the last part of the question. Find the area of the shaded region ABC. Okay, so this shaded region ABC is what we are supposed to find. So think about it this way, right? We can actually find this area over here. So let me shade it in a different color. So this area over here is actually a right angle triangle, right? Think about it. So the distance here is actually 1, right? And the distance here, okay, is actually minus 4 over 3. No, sorry. The distance here, to be precise, from here to here, okay, is actually minus 5 over 3. It's actually minus 1 minus 5 over 3. So the distance here is actually 2 over 3 units. Okay? So let's erase this thing inside. Yeah. So to find this area of this right angle triangle, okay, so we call, let me just name it as area of right angle triangle. Yeah. Maybe to be more precise, right? Let's call this point over here point D. Okay? Let point D, okay, be minus 1, 0. Okay? So that I can write it out more precisely. So area ADB, okay, this is a right angle triangle. Now this area is actually equals to half times 1 times 2 over 3, which equivalently is 2 over 3 units squared. Okay, sorry, 1 over 3 units squared. Okay, that's the area ADB. Now, knowing this area ADB, right? So this is area ADB, correct? Which is over here. So I try to shade it. So this is area ADB. Now I just need to find this area here under this curve over here. If I can find this area, I just take area ADB minus this area that I just shaded in light in this color, in green. I guess this color is green. Okay, I take the area ADB minus this shaded color in green, or the outline area here in green. I can get the area of the shaded region ABC. Okay, So this shaded area over this area outlined over here, right? This shaded area is actually the area under the curve, okay, from minus 4/3 to minus 1. So this area that I have outlined here, right, I repeat, is actually the area under the curve from minus 4/3 to minus 1. So in that case, area under the curve from x equals to minus 4/3 to x equals to minus 1 is integral of minus 4/3 to minus 1 square root 3x plus 4 dx. So this is actually equals to 3x plus 4, 1/2 plus 1 over 1/2 plus 1. Remember to times 3 because of this value 3 over here. So minus 4/3 minus 1. Okay, so this is actually equals to, let's see. Okay. Sub minus 1 inside, we get 3 minus 1 plus 4, 3/2 over, this will be actually equals to 3/2, 9/2, okay? And then minus, sub this inside, this will give me 3 minus 4/3 plus 4 divided by 9/2. Okay, so sorry, I missed out the power. So power 3/2 over here. Yeah. So this is equals to 1 to the power of 3/2 over 9/2 minus, here is also, here is actually, so this numerator is 0. So there's nothing over here. Yeah. So 1 to the power of 3/2. Because 3 times 3 is, so 3 cancel with 3, sorry, is nothing, 1. So we are left with minus 4 plus 4, which is 0. So 0, which is the numerator, divided by 9/2 is 0. So this whole thing is 0. So we don't have to bother about that one. So we are left with this, which is equals to 1 over 9/2, which is equals to 2 over 9 units squared. Okay, so that's the area under the curve from minus 4/3 to minus 1 as outlined in this green over here. So now we're going to take this area ADB, minus this area under the curve outlined in green from minus 4/3 to minus 1. We will be able to get the area of the shaded region ABC. Okay, so we're going to take 1/3 minus 2/9. So therefore, area ABC, okay, area ABC, so area of shaded region, area of the shaded region ABC equals to 1/3 minus 2/9, which is equals to 1/9 units squared. And we are done with this question.